This video is Module 1, Networking Today, for Introduction to Networks, version 7.02 for the Cisco Networking Academy course. The module objectives in this video are how networks affect our lives, network components, some common types of networks, internet connections, networking trends, network security, and the IT professional. So how do networks affect our lives? Networks allow us to communicate with others. They are almost important to us as air, water, food, and shelter, because what we do in our day-to-day lives requires communication with other humans or other computers, and the communications that we have today help us do that. Networks allow us to have no boundaries. We can communicate with others around the globe. We can bring global communities together, and we can create human networks using the computer networks. So with network components, we have host roles. Every computer on a network is called a host or an end device. Servers are computers that provide information to end devices. Those can be email servers, web servers, or file servers. Clients are computers that send requests to the servers to retrieve the information, such as web pages or emails from an email server. With a peer-to-peer network, it is possible to have a device be a client and a server in a peer-to-peer network. It's really only recommended for very small networks, and it can be things like print sharing or file sharing. It is easy to set up. They are less complex than a regular network, and there's a lower cost to them. They're usually used for simple tasks like transferring files or sharing printers. An end device is where a message originates from or where it is received. Data originates with an end device, it flows through a network, and then it arrives at an end device. So you can have a LAN on one side, you can request information, it goes through the internetwork, and then it goes to the other LAN or the other side, and then transfers that information back. Intermediary network devices connect end devices together. Examples of those are switches, wireless access points, routers, and firewalls. The management of data as it flows through a network is also the role of an intermediary device. It can regenerate and retransmit data signals. It maintains information about what pathways exist in those networks, and it can notify other devices of errors and communication failures so that those can be corrected. We have network media, and that's what allows network information to be transmitted between devices. We can have metal within cables or metal within cables. Those use electrical impulses across the metal through wires. You can have glass or plastic fiber optics. Those use pulses of light. Wireless transmissions use some type of modulation with frequencies like electromagnetic waves or radio signals. When we represent a network or when we design a network, we need to have a representation of it or a model of it so that when someone else looks at the network, they know where everything is. So network diagrams are often called topology diagrams. They use symbols to represent devices within the network. Some important terms that we talk about with networks is network interface card, or a NIC, N-N-I-C, physical ports and interfaces, and as a note, sometimes an interface and port are interchangeably used together, so just be aware of that. Topology diagrams, we have two types of those. The physical topology diagram illustrates the physical location of the devices and the cable installation. So if I wanted to tell you to go to server room 2158 and find router 1, I could find router 1 on rack 1, shelf 1. And then on the logical topology, that demonstrates or illustrates the device's ports, the addressing scheme of the network, and it ties to the physical topology, because then if I want to say I want to find router 1 is here, but I don't physically know where it is, I can go to the physical topology and know where it is physically, but I come to the logical topology to know that what ports are being used, and then when the networks are tied to it, what those network IP addresses are being used. Now, some common types of networks that we use. We have a lot of different types, and you're going to hear a lot of different acronyms, and I'm just going to go through these really quickly. We have small office or small home networks, or small networks, or you'll hear home networks. Those connect a few computers to each other on the internet. So you might have one or two computer devices. You might have a gaming device. You might have some security cameras that are connected together. You might have motion devices or something like that that's on a small network or a small home network. And then we have SOHO, or small office home office. That usually comes with remote work that's connected to a corporate network. So if someone's working from home or they have a small office in their home, they will call that a SOHO, or a small office home office. The medium to large networks, those are gonna be your most that you see in the world. We have hundreds of thousands of internet connected computers all over the world, and those are connected with medium to large networks. And those can range anywhere from 5 to 10 computers up to thousands of computers, depending upon the size of the corporation or the company or the location. And then we have worldwide networks. Those connect hundreds of millions of computers worldwide, such as the internet. The internet is considered a network, and the World Wide Web, or the Worldwide Network, or Worldwide Internet, or just the internet, is considered a worldwide network. LANs and WANs are two acronyms that you'll learn or need to know: local area networks and wide area networks. And I think I said wireless area networks earlier, and I meant wide area networks. Network infrastructures vary greatly in terms of size of the area they covered, number of types of services, and the area of responsibility. So a local area network would be like a home office. Right here, I'm going to segment that off. You might have a central office, or your corporate office. You might have a branch office over here, and those are all the local area networks. So we might have 1, 2, and 3 local area networks, and those are connected together through the internet or through the cloud, and then those are connected using a wide area network, or a WAN. A LAN is a network infrastructure that spans a small geographical area, usually one building, maybe two buildings, a couple of floors in a building. Interconnected in devices in a limited area. LAN also is administered by a single organization or an individual, and it provides high-speed bandwidth to internal devices. A wide area network, or WAN, is a network infrastructure that spans large geographical areas. They connect LANs together. They're usually administered by one or more service providers, and they typically provide lower speed links between the LANs. The internet is a collection of LANs and WANs around the world. LANs are connected using WANs, and WANs use copper wires, fiber optic cables, and wireless transmissions. We don't know how they're all connected. That's why we call it a cloud, because we don't know what's in the cloud. We just know that those devices are connected in some way, and we connect to those and transmit data. So the internet is not owned by any one individual or group. You have different groups that maintain the structure on the internet, the IETF, ICANN, and IAB. You can look all of those up on the internet. If you're in your course, you might ask your professor about those, or your instructor about those, or you can go look those up on the internet. A couple of other terms that we talk about are intranets and extranets. So we know the term internet. That's where we have a lot of devices that are connected around the world. But an intranet is a company-only network. So we can have a wiki, we can have a Wikipedia page, not a Wikipedia, but we can have a wiki page, or we can have information that's located just within the company, and that's called an intranet. And then we connect to suppliers, customers, and other collaborators or other people that connect into our company, and that's what we would call an extranet. It doesn't mean everybody on the internet can see it legally. Someone might hack in, but those that are authorized are on the extranet. They're not on the intranet. They're not connected directly to the network, but they have some type of connection in, and that would be considered an extranet. And then we can connect using the internet to tie all those together. Now, with internet connections, we tie into some type of service provider. Some of the popular services for home and small offices include broadband cable, digital subscriber line, or DSL. We might have wireless WANs, or we even have mobile services in some case. Now, larger organizations need faster connections to support IP phones, video conferencing, and data center storage. So they're going to have faster connections that do cost more money. And then you can have business class interconnections. Those are usually provided by a service provider, and they might include business DSL, lease lines, or Metro Ethernet. For home and small office internet connections, we have cables. That might be an internet provider would run a cable to your house. That's high bandwidth. It's always on. You might have their router in your home or your office that they provide, or you can provide your own router that connects to them. You can have DSL, digital subscriber line. That's high bandwidth. It's always on. It runs over a telephone line. You can have cellular. That uses a cell phone network to connect to the internet. It's not as fast, but it does provide a backup in some cases. You can also have satellite connection. I personally have used satellite internet connection in the past. It has major benefits to rural areas. I lived out in the country. I did not live next to a city, so I had to use satellite. So my down speeds were real quick, and my upload speeds went through the telephone line, the regular old telephone line, or POTS, plain old telephone service. And my uploads would go through the telephone, my downloads would come from the satellite. And then you can have dial-up telephone. Those are not very, you're not going to see those a lot anymore, but they are still out there. They're inexpensive, they're low bandwidth. It's an option using a modem, a modulator, demodulator device. Like I said, you won't see those very often anymore, but they are still around in some cases. Business internet connections are going to have dedicated lease lines. Those are reserved circuits. The provider will come in and put a box or a device, an endpoint into the or an exit point. There's different terms for it, but you'll put a device in the building and you'll connect to your net. You'll connect your intranet, your local area network to that device, and then it will go to the service provider and then out to the cloud. You can have Ethernet WAN. Those extend LAN access technologies into the wide area network. DSL, again, digital subscriber line. You can also have symmetric digital subscriber line, which gives you higher speeds. And then you can also have satellite connections in a business service. When we talk about the converging network, before we had converged networks, an organization might have had a separate cable for telephone, one for video, and one for data. And now what we're doing is we're having all of those services go across the same network or a converged network. So we can use, so instead of having a device go across its own connection for network and then phones and for video or video conferencing, all of those now go through the converged network. And the converged network will take data, voice, and video, mash all of those together. Well, they don't mash them together, but they all use the same medium, whether it's a cable or wireless, and they will carry them across the same network. When we talk about reliable networks, we have to have network architecture that fits some points here. The first one is fault tolerance. So if something goes bad, we need to make sure that we have other hardware that's going to take its place, or what we call fault tolerance. So if one switch goes down, we've got another switch that will take over, or a router that will take over. We also have to have quality of service, or QoS, which means we have to have fast enough speed, and we need to not have any packets dropped, network packets or information dropped. We need to have scalability. We need to be able to take the network and make it larger if necessary to add in more users or more bandwidth. And then we need to have security, which is probably one of the most important pieces, and you'll get into that in some later modules where we talk about network security, but we need to be able to make sure that those that enter the network are supposed to be in the network. So fault tolerance, scalability, QoS, and security. With fault tolerance, that means that the impact of failure is limited to the number of affected devices. So multiple paths are required for fault tolerance. So reliable networks provide redundancy. That's the big word there, redundancy, by implementing a packet switch network. So if one router goes down, those packets can be routed and go through another router. So you may have two routers on your local area network or your network that are connecting out to the cloud, so that if one goes down or is having problems, everything can switch to the other one. Now everything may slow down, but you still have network going out. We need to have scalability. So let's say that this was our original network right here, and then we added another piece to our business, and they said, hey, we need to add 3 more computers, or 30 more computers, or 100 more computers. What we can do in that case is we can either add another router on even. We could add another router in to the network, and those could connect in, and we could connect those. Well, that one's connected, cross-connected there, but we could connect those in in another manner so that we can add more devices in, or what we call scalability or scaling. QoS just means that when we have voice and live video transmissions, those do require higher expectations for those services, so that we need to make sure that those bits of information, those packets, are going through the network in a manner that's going to keep the service available. If you've ever watched a video where someone starts dropping off or it starts getting choppy, that just means the QoS is dropping and that they're having some kind of network problem. Well, in the network that we're talking about here are reliable networks. We need to make sure that the QoS is available for those services. And then network security, even though it's last here, it is still really important. There's two types of network securities that need to be addressed. We have network infrastructure security, the physical security of the network devices. Are your devices behind locked doors? Does it require some type of ID to access those areas? Does it require, the locking mechanism? Is it easy to unlock those, or does anybody have access to those? You want to make sure that you have restricted access to those physical network devices. And then you have information security. You want to protect the information of the data being transmitted over the network. And that's a whole other area of networking and networking security. But you have physical security, and then you have information security. So we have three goals of network security, and we call it the CIA. And no, that's not an agency within the United States, but we call it CIA. And that's how I remember Theseus as well. It's CIA confidentiality. That means only intended recipients can read the data, so it's confidential. It's integrity. That means the assurance of the data has not been altered within the transmission. So it's an integrity, or it's intact. And then it's available. That means the assurance of timely and reliable access to data for authorized users. So CIA, confidence, integrity, and availability. Or confidentiality, integrity, and availability. Now, with networking trends, and this has been going on for a while, but we have companies do what we call BYOD, or bring your own devices. So companies do allow, in fact, encourage or require, in a lot of cases, you to bring your own personal devices into the organization. I use my phone for two-factor authentication. I've stripped off all apps off my phone now that my company, I don't use any of my company. I use a VM, but a lot of companies do the bring your own devices, and those devices need to be secured by the network so that they're not bringing in or introducing something with security that's a hole in your security. They also allow online collaboration, video communications, and cloud computing. The bring your own device could be a laptop, a netbook, smartphones, e-readers, any one of those type of devices. It just means that the ownership is not the company, or it's not by the same people that have the network, but they can be used anywhere. So BYOD, or bring your own device, it just means the end user has the device, and then you're allowing them onto your network. Online collaboration, everybody's familiar now with different types of, Cisco has WebEx, there's Zoom calls, you have Twitch streaming with video gaming, you have YouTube streaming, you can collaborate with others over the network on joint projects, and that's what the networks allow you to do with collaboration. Video communication, video calls are made to anyone, regardless of where they're located, as long as they have a connection to the network. Video conferencing is a powerful tool for communicating. It really, really took off after COVID and everyone got locked down. And so we had to have a way to communicate that was separate and not physically in the same place. And so that's where video communication really took off. And over the last 6 to 7 years, this video is being done in 2026. Over the last 6 years, video conferencing and video communication has really become important. And then last term we're going to look at is cloud computing. Cloud computing allows us to store personal files or backups in the cloud. And it's called a cloud because we don't really know the hardware. We know how to connect to it, but if you connect to an Amazon Web Service or an Azure Web Service, or you've got some type of even a network that is in a company, but we don't really know what the hardware is or how everything's set up. We just connect to it and we can do things in the cloud. They may provide a service for us. They may provide video conferencing. They might provide some type of storage, web server, print services, something along those lines. But that's cloud computing because it has a data center somewhere that's providing that service. And there's 4 different types of clouds. You have public clouds. Those are available to the general public. You pay to use those. and there's even some free models. You have private clouds. Those are intended for specific organizations. Governments will set up private clouds, and only those authorized can connect to them. You have hybrid clouds. Those can be cloud mixes, and then you can have custom clouds that are set up. Now, with technology trends in the home, you have smart home technology. Cars are now being connected to the internet. They've got cameras in cars, internal and external. You have the tracking, all the tracking data. Newer cars that are less than probably 5 years old have all kinds of tracking data on them. They can tell you the how much tire pressure you have. They can tell not just you, but they also track the data and send it back to whoever owns the car. And I don't say you own the car, because they still own the car, because they control all the technology on it and they control all the data. They know when you start the car, they know braking, they know speeds, they know where you were located, GPS location. And if you connect your phone to the car, that's all getting connected. Your home devices, if you have smart appliances, so if you have a refrigerator or a washer and dryer or a stove or a cleaning device that moves around that's got some type of IoT, Internet of Things device that's connected, those are all being put into the cloud and tracked, and those can only operate with a network. This is not seen very often, but you may come across it in the networking world, but it's called power line networking. You can use regular power lines in your home or in an office to do networking. So you just send the network across, and it's called power line networking. I'm not going to spend a lot of time here on this slide. If you want to pause this and read over it, you can, but it's just you use electrical lines to do your networking. Wireless broadband is just high speed, or it's found in rural areas, but it's what we call a wireless internet service provider, or a WISP. It provides another solution for homes and small offices that are maybe not in larger towns. They're rural or out in the country is the term to use. Now, with network security, we have physical security, but we have also network security or data security. You have external threats. Those are viruses, spyware, threat actor attacks, someone trying to get in, a denial of service attack, someone that's trying to shut your network down so that other people can't get to it. That can be a DOS or a denial of service. You can have internal threats, someone that inside your network that steals a device or accidentally plugs something in. They pick up a USB device, they download a piece of software. Those are also, so we have external and internal threats, but the internal threats sometimes are more important to watch out for than external threats. So with security solutions, we implement a number of different things. We have antivirus and anti-spyware devices. We have firewall filtering used to block unauthorized access to networks. And then we have just monitoring. We set the network up from the beginning with security in mind, and then we put the software in place. We also have network appliances that do these different roles, and then we have constant monitoring. With larger networks, we can have dedicated firewall systems. We have access control list, or ACLs. We have intrusion prevention systems, or IPSs. Virtual private networks that allow someone that's authorized to connect into our network by using a virtual private network. And then finally, we're going to look at the IT professional. The CCNA track, this is the current one as of the summer of 2026. We have the Cisco Certified Network Associate, or CCNA. The new CCNA, or the CCNA, focuses on IP foundations, security topics, wireless, virtualization, automation, and network programmability. You can go to netacad.com, and if you're watching this video, you probably already are enrolled in a Network Academy or a Cisco Network course, and you're watching this as follow-up information. But you can go to netacad.com. You can go and look for employment opportunities, and there's a talent bridge matching engine in there. You can search for jobs, you can search for information, and then there's a lot of different places on the internet that you can look for careers as well. And then for Module 1, these are some of the new terms and then commands that were introduced. So I'm going to leave this screen up for a few seconds for you. If you want to pause the video, or if you want to take a screenshot, you can get these. And thank you for watching.